Oh, yeah, there's a couple people in there. Hi, couple people that are in there. Cool. Now, as I mentioned, word problems are typically high school students' most hated type of math problem. I know what most high school students do with word problems. They skim it. They look for numbers that might be important. And they kind of hope that if they stare at it long enough, it'll make sense. Tell me I'm wrong. I know I'm not wrong. Now, last week, what's up? A little bit. Last week, I gave you that anecdotal story of me putting my thumb on the oven. Remember that? You don't? She remembers. Okay. Did I tell you about the sandbox? Sandbox? No? I want you to imagine a sandbox. A sandbox that you walk up to, and there is a quarter sitting right on top of that sandbox. Now, imagine that you are 6 years old. You're 6 years old, you walk up to the sandbox, and there's a quarter sitting right on top of it. As a 6-year-old, what do you do? Because it's yours now, right? Yeah, shiny. I want that quarter. Good. Then, the next day, you walk up to that sandbox. You're 6 years old. You look at the sandbox, there's nothing there. Somebody tells you, hey, there's a quarter buried in the sandbox. Now, let's say they're telling the truth. Let's say that there actually is a quarter buried in the sandbox. So, 6-year-old you is going to look at that sandbox and you're going to get that quarter, but you're going to get it like this. Ready? I couldn't get the quarter. I couldn't get it. It's too hard. I'm going to walk away. What did I do wrong? I did something. I did try. No. I tried. Look, I'll do it again. I'll do it again. I know, right? Say again? Well, I did put an effort, but she's correct. I didn't put in the right type of effort. I didn't actually dig. I just stared at it, and I kind of hoped that things would work out for the best. Almost like math students when it comes to a math problem. How do you get the quarter? You grab it. You got to dig. As she just said, you got to dig. You have to be willing to get your hands dirty. You have to be willing to make mistakes. You have to be willing to put your thumb on that stove. You have to be willing to be wrong in order to get corrected and learn how to do it correctly for the future. Actually, I have 4 people in the chat right now. Are some of you in the chat? All right, that was weird. I got 4 people. Hey. He said hello. All right, back to this. Now, for those of you in the chat, in the Google Classroom, there is a PDF in the stream that I posted yesterday, I believe, and it looks like this. And I'm going to be working off of this worksheet, so you can click the PDF and you will have the problems right there on your computer. For the rest of you, I'm going to give this to you right now. My goal for today is all types of word problems. Not all word problems are created equal. Not all word problems have the same strategy. Depending on the word problem and depending on the context of the problem that you're dealing with, you may have to do something slightly different from problem to problem. That is my goal for today. That is what I would like to do. So again, for those of you in the chat, if you want to get that PDF open, that's fine. I am going to put this paper underneath my Elmo camera. So it's going to be up here, but I'm going to write on it. But again, it might be difficult to read from the computer. Everyone in the room has a physical copy of that particular worksheet. So here we go. I'm going to suggest to all of you that if you want to put your work directly on this worksheet, by all means, you can go ahead and do that. But it may be in your best interest to put all this work on a separate sheet of paper. Putting it in a separate sheet of paper might be better, but again, that's up to you. That's up to your notes. Let me flip my camera over. Flip. Click. There we go. Let me zoom in on this thing. Now, again, this might be a little difficult to read from where everyone is sitting. We're going to try and do our best with this. Let's talk about what has to happen now. I'm very sad that it's October. During the month of September, teachers were given free coffee at Wawa. I could go in twice a day and get a free coffee. You guys show an ID. You know how you guys have student IDs? Yeah, you just get the coffee, you go up to the register, teacher ID. And then we high five. Anyway, number one, plot of land has a width of X feet and a length of that is 8 feet less than its width. A farmer will only purchase the land if it measures 240 square feet. What value of X will cause the farmer to purchase the land? Some word problems are a little bit more straightforward than others. This one, you do have to infer a little bit. Do they tell you the shape of the land? They don't. Ooh. Based on the context of the problem, could you figure out what shape the land has? Ooh. Not a square. Square would have 4 equal sides. Definitely a rectangle. It's definitely not 4 equal sides. One side has a length of X. The other side has a length that is 8 feet less than X. So I'm going to draw a picture. Oh, my chords. Come here, chords. There we go. Let's see what we get here. If I were to draw this picture out, be some kind of a rectangle with a length of X feet and a length of X minus 8 feet. Okay, that could work. What is the area of this plot of land? What is the area of this plot of land? They tell you right in the problem. 240. It's 240 square feet. Square feet implies area. Square feet implies area. How do you find the area of a rectangle? This goes back to geometry. How do you find the area of a rectangle? How do you find the area of a rectangle? Just length times width. Now, I'm just trying to piece all of these clues together. They don't tell you the type of shape that you have. They tell you the area is 240. They give you a length and a width, so it implies it's a rectangle. To find the area of a rectangle, length times width, and it has to be equal to 240. These are all the context clues that we need to put together in order to come up with an equation that we are eventually going to solve. So this should be something like X times X minus 8. There is your length times width. And it should be equal to 240. Now, ultimately, we are going to be solving all of these. We're going to be solving all of these using something that would resemble the Tucker method. Sorry, I'm hoping that this... Yes! Sorry. Yes. Yes. Yes, so you fill out this pass. Sorry, I'm just very excited. I just got an email from my kid's teacher. You can fill this out for me. I'm going to put this underneath my my thing right here. My kid's teacher just said, so this just happened. He lost his second tooth. Lost the second tooth. Look at that. Everyone be jealous. My kid's tooth, or I'm sorry, we have that. My kid's bottom 2 teeth. Oh, it just fell at the top. I'm sorry. My kid's bottom 2 teeth were so loose for so long that his adult teeth started growing in. Have you ever seen a kid with shark teeth? Oh, I haven't signed it yet. Have you ever seen a kid with shark teeth? You know what shark teeth is? You don't start losing your teeth till you're like 5 or 6 years old. No, typically you lose either the bottom 2 first or the top 2 first. Nope, 5 or 6 years old. But my thing is, his adult teeth started growing in. So it looked like he had 2 sets of teeth. It was crazy. They finally dropped. Oh, he does. The kid eats like 2 apples a day. Yeah, he adapted. Anyway, let's do this. Now, in order to solve this quadratic, I'm going to have to simplify some stuff down. To simplify the stuff down, I'm going to do a little distribution. Now, distribution may be as simple as what I'm doing right here, but it also may have to end up being FOIL or the box method that I taught you. Well, we'll get there. X times x times -8 equals 240. Now I'm ready to solve this. Now I'm ready to get this thing done. Oh, man. Something's wrong with this. X plus x is 2x, but x times x is x squared. Think of it as, give me some number that's not 2. Okay, 5 times 5 would be 5 squared. Yeah. Just like 5 plus 5 would be 2 times 5. But anyway, I can't solve this yet. Something looks wrong. Something looks weird. I want to do the Tucker method. I got to do, before I even get to the Tucker method, what do I have to do? What do I have to make sure of? It has to equal 0. It has to equal 0. All of these problems, whether it be these word problems or your project problems, it doesn't matter. You have to get one side of this thing equal to 0. So sometimes it's very simple and straightforward. Sometimes it's just a matter of, I just have to subtract 240. Cool. Now I'm ready to begin. See, the thing is, everything that I've done up to this point has been set up. And I'm taking this deliberately slow with you because I want you to see the process that you could go through. Reading the problem, pulling out the proper pieces of information, setting up a strategy for getting this thing done, simplifying it down, getting it equal to 0, and now we'll begin the Tucker method of factoring, or whatever method of factoring you already know. So I could do a little a times c. I get -240. Ugh, -240. That's going to take forever to find those two magic numbers. I mean, okay, 240 divided by 10. That can't work. They got to add up to -8. 240 divided by 12. Oh, that could work. 12 and 20. Which one has to be negative? Has to be -20 in this case. -20. +12. Technically, you don't have to do a t-chart here because it's a 1x squared. If you did a t-chart, it would be 1x and 1x on the top of the t-chart, which would not simplify. So you could just go straight to x minus 20, x plus 12 equals 0. Now for this problem, for this equation, I'm going to get two answers. Once you have them equal to 0, and factored, once you have them multiplied together equal to 0, you can set the individual pieces equal to 0 and solve. This one right here would look like x minus 20 equals 0, which would produce +20. This one would be x plus 12 equals 0, which would produce -12. Yay, we got our two answers. But again, this is a word problem. This is a word problem. Word problems have context. Word problems deserve answers. Is there anything left of the 2x8? I can't see. Oh, I apologize. Let me try to change this a little. Move this up just a tad. I'm hoping that you could see that a little bit better. Okay, hopefully she can. It's a word problem. Which one actually is my answer? Which one is actually my answer? The 20. Now, one might argue because the 20 is positive and the 12 is negative, but I need something a bit more specific. Why can't this be a -12? You can't have negative length or negative land. Yes, the 12 is negative. That's not enough to get rid of it. It's enough to get rid of it to realize the context of the problem. The context of the problem is that you can't have a negative length. As a result, the answer has to be 20. It has to be 20. So I'm going to go back to the beginning of the problem, and I'm going to figure out what they were even asking. What value of X will cause the farmer to purchase the land? Oh, well, X equals 20, which would give me dimensions of 20 feet by, if I plug the 20 in here, 12 feet. For the project, there are going to be various times where you have to go back and give me the dimensions of that particular thing, situation, event, whatever it ends up being for the project. For the project, you're going to be designing a pool complex. It's going to be nice. Multiple pools all within a rectangular region. It's going to be great. Now, here's what we're going to do. In a moment, I'm going to set up number 2 for you. I'm going to set it up. And then I'm going to have you finish it. And you're also going to do number 4. In a moment, I'm going to set up number 2, and then you are going to finish number 2 and complete number 4 as well. Let's talk about number 2. Number 2, in business, the break-even point is the point X, Y, at which the graphs of the revenue and cost functions intersect. For one manufacturing company, the revenue from producing X items is given by the function Y equals 2X plus 12, and the cost of producing X items is given by the Y equals negative X squared plus 10X plus 5. Find all break-even points. I need you to be honest with me. Be honest. Be honest. Be honest. When did you kind of tune out me reading that question? Yeah. At the word business. Yeah. I'm being complete. I know exactly what high school students go through. I read something like that and it literally, it's like white noise. It's like white noise when you hear somebody read something like that. This is why people hate word problems. They look at something like this, and they're like, what the heck is it even asking? I understand that. It is your job to decipher what this thing is saying. Hmm?
Ask a drunk dude, what's bigger, like 2/3 or 3/5? They'll say 3/5, but if you say what's better than 2 things to buy for 3 people or 3 things to buy,
it makes it a bit more sense in context. Yeah. Here's the thing. There's no well, there definitely is a wrong way. But if you were comparing 2 teaching styles, it is a subjective argument to say that one is better than the other. It's subjective because, like, for me, you know what worked for me? When I was a kid, literally flashcards and memorizing facts. That's what worked for me. That doesn't work for everybody. You know, for me, it made perfect sense. I mean, clearly I'm not having you memorize like flashcards, you know, but anyway, your job is to decipher. Your job is to use the context of the problem and figure out what the heck it's even asking. Let's go into the details of this. First of all, revenue versus cost. A company, when they sell something, has a certain amount of revenue. That's money that they take in. But there's a certain level of cost in which they have to spend in order to get that product out there. The difference between the two is your profit. I can sell this, I don't know, this meal for $10, but it cost me $5 to make the meal. Thus, I only have a $5 profit. Okay. Usually when companies begin selling stuff, they start really in the red. It's, if you've ever like heard people talk about companies and where their profits are, it's either they're in the red or they're in the black. What do they call the Friday after Thanksgiving? Why? That's when most companies for the year go from the red into the black because they're selling a lot more stuff. That's why they call it Black Friday. You learned something today. But there's a break-even point. The break-even point is when my revenue and my cost equal each other, when they equal out. When I have made all of this money from revenue and I've spent all this money to put the product out there, and this is the moment that I'm going to break even. And after this moment, is all profit. This is what this question's saying. For one company, the revenue function is given by this, and the cost function is given by this. And they're basically saying, when will the two equations be equal? When will they be equal to one another? That's the deciphering that you have to do. So, if literally I'm trying to find out when this equation will equal this equation, it's just a matter of 2x plus 12 equals negative x squared plus 10x plus 5. There is the setup to the problem. Literally, just set them equal to each other. Now, I can't solve it yet. I can't use my quadratic solving and factoring skills in order to get this thing done. Why? Why? It's not equal to 0. Yeah. That's what you have to do. I would suggest moving everything over to the left. Move everything over to the left. Because you really want that x squared to be positive, so you're going to add that x squared to both sides. But then you're also going to move over the 10x and the 5. Is what you guys are going to do. I'm going to give you the next chunk of time, maybe 5 minutes or so. Maybe more, maybe less. I want you to finish number 2. And I want you to get done number 4. I'm going to skip number 3. I'm going to go over number 3 with you together. But for right now, I want you to complete number 2 and knock out number 4. Go.
How can, so if we're trying to find something for 7, how the AC, how would that equal something that's even bigger than 7? 8, even though it's negative still.
Give me 2 numbers that multiply to 7.
2 numbers that multiply to 7.
Yep.
3.5 times 2.
Whole numbers. There are. There's a 1 pair.
1 times 7.
Now, what's 1 plus 7? Okay, but you need it to equal.
Negative 7.
Yeah. A lot of people end up forgetting the 1.
I never thought of that.
After you finish out number 2, I'll let you knock out 4 as well. Well, keep in mind, all you've done up to that point is you have, well, mind you, a couple things. Number 1, both of them have to be negative, the negative 1 and the negative 7. You have to multiply to positive and then add up to that negative 8. Yeah, just for the sake of argument, make sure you write out the factors and then get the 2 solutions. Now, the 2 solutions, it is going to go a little bit farther than what you've done, But you'll see when we go over it. But definitely for number 4, you could knock out number 4, draw a picture for number 4. That might be helpful. Alexa, I did see your comment in the chat. Technically, I guess, yes, you can. You still don't have it equal to 0 yet. You would have to subtract the 12 as well. But keep in mind that that is not the way that I am going to show how to get that problem done. The reason being is because since it is a negative x squared, having a negative x squared or a negative a value is not going to help very much in terms of using the Tucker method. It would be much easier for everyone involved if the a value, the x squared number, the number in front of the x squared, were positive. So what I'm going to do is I am actually going to move everything over to the left side of the problem. By, instead of the 2x, I'm going to subtract the 10x. I'm going to subtract the 5, and I'm going to add the x squared to both sides. That is the much easier way of handling that type of problem. Bring this with me. Okay. Let's see where we're at. Zipping in, zipping in. Now, as I mentioned before, I mentioned this verbally. I was going to add the x squared to cancel this out. I was going to subtract the 10x. And I was going to subtract the 5. Doing that will guarantee me the one side of the equation being 0. But as I said, I really, really wanted it to be a positive x squared. So I end up with positive x squared minus 8x plus 7 equals 0. Move that up a little bit for the glare. Now again, for the Tucker method, it's the same concept for the Tucker method. A times c is 7. But you're trying to find two numbers that multiply to 7 and add up to negative 8. That has to be negative 7 and positive 1. Now, setting each of those terms equal to 0 gets you your two answers of positive 7 and positive 1. So now I turn the question to each of you. Which one of those is correct? I got two answers at the word problem. Which one's correct? Technically, in this case, it would definitely be both of them, yes. Let me show you a visual. I'm going to go to Desmos. Desmos.com. Graphing calculator. Y equals 2x plus 12. Y equals negative x squared. What was it? Plus 10x plus 5. Come on. Oh, I didn't put it down in the bottom spot. Cut, paste, 2. There it is. So I got a green graph and I got a red graph. How many times did these two graphs cross each other? Twice. And wouldn't you know it, look at the x values of the intersection points, the x values. Now, what's interesting to me is these other numbers. Look at the number on the bottom left. 1, 14. Where the heck did that 14 come from? It says 7, 26. Where did the 26 come from? Let me go back to this real quick. If I'm looking at these two answers right here, it said 1, 14. Where did the 14 come from? Do you know? Go for it. Yes. Yes. Because, and I'm going to use a highlighter, they wanted the break-even point. And the break-even point is an ordered pair x comma y. You didn't have to do this for the other problem. You did not have to plug that number back in order to get a y value. This problem you did because of the context. The context of the problem demanded it. So in reality, 1 comma 14 is one of my answers. And I'm just going to repeat exactly what you just said. You said to plug the 1 in. 2 times 1 is 2, plus 12 is 14. 7 also works. Yes, it does. It's a break-even point. Because look at the context of the problem. The context of the problem says, if the two equations, or it doesn't say this, it implies this, the two equations would quote-unquote break even when these two equations are equal to one another. Visually, look at it. They're equal to one another. They cross each other. They intersect each other. In fact, they do say that right here. It says when the graph of the revenue and cost function intersect, when they cross each other. That's exactly what's going on here. Both of those answers technically work. Let me get the, there is Google Classroom. What is this? I need to get the chat up over here because I'm going to be writing some stuff and I don't want to keep going back and forth to the computer. Go ahead.
Well, we just put the 7 into 2x plus 12.
Either one.
Not that's a negative.
Yeah, check this out, check this out, check this out. So 2 times 7 plus 12 does give you 26. But check this out, negative parentheses 7 squared plus 10 times 7 plus 5. Same exact number. It's really crazy. Same thing works with the 1. Check this out. If I plug the 1 in here, and then I do the 1 right there, gets you 14 both times as well. It's kind of nice. So, number 4. I suggested for number 4 that you draw a picture. A square has 4 equal sides. One of those sides is increased by 2. One of those sides is decreased by 2. I got you. There you go. Move it up more. One of those sides is increased by 2. One of those sides is decreased by 2. That's what I would like to start with. The area of the resulting rectangle is 32. So basically, you are back at a problem like number 1. You are back at a problem like number 1, except now it looks like this. I got to multiply this crap together. I got to solve this thing out. Oof. You guys learned FOIL in Algebra 1? First, add, or enter last? I heard a yes, I heard a no. I'm not a fan of FOIL. Hurts my teeth. I really don't want to mess with it. I mean, you can if you wanted to. I prefer this. I prefer doing a little box method here. Multiplying out in this box works just like FOIL, but it's important to know how to do this. X times X, 2 times X, negative 2 times X, negative 4. Let me zoom in. What the heck happens here? Yes, they do. You said it even before I even got to it. But yeah, when you combine like terms, they cancel each other out. So you're left with x squared minus 4 equals 32. Because you got to get one side equal to 0. So it is. Let's talk about that. I want to fill the chat in on what you just said because they can't hear you, which is fine. He's telling me that I needed to use, for this quadratic here, magic numbers of 6 and negative 6. And that is correct. My question is, why? Why do 6 and negative 6 work? First of all, what is 6 times negative 6? Negative 36. What is negative 6 plus 6? See, the thing is with this problem, and let me come up to the board to show you this, is that typically, actually, no, I don't want to use red. Let's use black here because I want you to see it. I put a squared. Technically, it's ax squared plus bx plus c. That was a bad sneeze. I hate these masks. Anyway, but what's missing from this problem? What's missing from the x squared minus 36? What's missing from this? Yeah, that middle term, that bx, which implies that it has to be a 0x. Your two magic numbers work. They multiply to negative 36, and they add up to 0. So, oh no, everything failed. Are we good? Are we alive? Are we alive? Fault. What did my kid say the other day? He said he was talking about his teeth. And he's supposed to be like, I lost my tooth. But he said he loosed his tooth. You hope they have a lisp? Why? Yeah, if you would be laughing at your kid for having a lisp, then you would be psychologically scarring them for life. Okay, I hope they come back and give you their therapy bills. Wow. And then you might die with them, putting a knife in your face.
Some 26-year-old kid.
At some point during elementary school, they might go through something called speech therapy. Yeah.
I had a list that I couldn't speak right.
So this is self-inflicted in pain. Wow. Anyway, back to this. X minus 6, x plus 6. You get two answers of positive 6 and negative 6. But, as is typical fashion, only that positive 6 is going to work. Because, the other one would produce a negative length. The question said, find the measure of one side of the square. Well, the measure of one side of the square is definitely 6. 6 what? Nope. Centimeters. In this case, centimeters. Context of the problem. Let's talk about number 2. I'm sorry, number 2. Number 3. Let's talk about number 3. Number 3, I purposefully did not have you do yet because I wanted to talk about it a little bit. Find two consecutive positive integers. All right. Do you know what the first integer is? No. Let's label the first integer. What would the first integer could be labeled as? No. I don't know, but you told me you didn't know what it was. You told me you didn't know what it was. Sure, let's call it x. The first integer is x. What's the second integer? No, it can't be the same. You could call it a. You could call it y. You could call it all of those, but I'm going to call it none of those. You know why? They're two consecutive integers. Give me an example of two consecutive integers. Give me two consecutive integers. Give me a number, any number. What's the one after it? There you go. You gave me two consecutive integers.
Oh, well, x.
You're getting closer.
X squared.
You're getting farther away.
2x.
X plus 1. See, but here's the thing. You started to realize what I was aiming at. You started to realize what I was aiming at. Two consecutive integers would be x and x plus 1. So now let's go to the problem. I know. This is the strategy. Again, my job is to teach you strategy. You know how to solve these. You guys know how to solve these. It's just a matter of throwing in that strategy. So, the square of the first decreased by 17 equals 4 times the second. The square of the first, look what I'm writing, decreased by 17 equals 4 times the second. That is the setup to the problem. Absolutely, I will. First, let me go back a tiny bit further. Do we agree that these, what I wrote here, x and x plus 1, that those are 2 consecutive integers? Like 6 and then 7, because it would be 6 plus 1. Cool. Now I go to the word problem itself. 2 consecutive integers such that the square of the first decreased by 17. That's literally what I wrote right here. This is called a literal equation. The square of the first decreased by 17 equals, fairly simple right there. When you see the word equals, I literally wrote the equal sign, equals 4 times the second number. That's how that was set up. They call them literal equations because I'm following the words and writing literally what it's telling me to do. Yeah. Different strategies for every problem. So, x squared minus 17 equals 4x plus 4. I distributed the 4. Then, as we've done with all these problems, I'm going to move everything over to the left. I end up with x squared minus 4x minus 21 equals 0. I had to subtract the 4x and I had to subtract the 4. So, now we're back at a quadratic that we have to solve. Again, Tucker method, finding 2 magic numbers, blah, 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 blah. In fact, I'll just skip ahead a little bit. Say it again. Be more specific. There it is. Yes. 7 and 3 definitely work, but because of the nature of where the negatives were, one of them definitely had to be negative. Put that up a little more. We get 2 answers. We get an answer of 7. We get an answer of negative 3. But, as always, we're not done yet. We're definitely not done yet. There's a couple reasons why we're not done yet. Go ahead. Negative 7 plus 3 would give you that negative 4. Remember, your magic numbers are not your solutions. Your magic numbers just help you get to your solutions. But I get that answer of 7 and negative 3 as my x values. But we're not done yet. First, tell me why one of those numbers don't work. So? Why is it a big deal that it's negative? You need a reason. You need a rationale for it. Sometimes negative answers will work. Yeah. That's the reason. Not just because it's negative. Remember before when we did that one problem, you told me that the negative 12 didn't work? And I said, why? And he said, because you can't have negative length. That was the reason. It's not just because it was negative. Negative 3 doesn't work. Not because it's just a negative number, but because the problem specifically said positive. So 7 is the only one that actually works. But what's my final answer? What did the question want? So what are my answers? 7 definitely works as an x value. So what answer do I present? Wait, what's that again? No, I just ignored the -3. He said 8. 2 consecutive positive integers. So the answer would be 7 and 8, 2/3 to a hilarious joke. 2/3 to a hilarious joke. Why is it 2/3 to a hilarious joke? If the problem never said the word positive, meaning that the -3 would work, it would be -3 and -2. Yes. Because if you think about it, yeah. If I plugged in a -3 here, -3 squared is +9. +9 minus 17 would give me, I can't even think right now, -8. And then the second number times 4, -2 times 4 would give you -8. Same thing with the 7. You plug in the 7, the first squared, so 49 minus 17. 49 minus 17 would give you 32. And then 4 times the second, which would be 4 times 8, would also give you 32. Why is it 2/3 to a hilarious joke? Because 7, 8. There you go. You know what they call that? There you go. I do. I literally just did. Let's talk about number 6. Let's toss a rock off a cliff. In this problem, tossing a rock off a cliff, I want you to imagine what this would look like. There's the ground. There's the cliff. There's the guy. Make him stand properly. There's the guy tossing the rock off the cliff. There's it hitting the ground. I want you to visualize this. The height of a rock is thrown off a cliff and can be modeled by that equation, where h is the height in feet and t is the time in seconds. How long does it take for the rock to hit the ground? T. First question. What's the height of the rock when it hits the ground? You do. Yeah. Think about it, the height of the rock. The guy standing on a cliff, he's elevated, right? In fact, he's actually 120 feet above the ground. Because if you plug in a 0 into the equation, a 0 for t, no time having gone by, that actually equates to 120 feet. But that's not what the question's asking for. The question is saying, when will the height of the rock actually be 0? Hey, y'all see my cute tees? My cute little tees? A little hook on the bottom. You know why I do that? Exactly. I did that in college. It was a lot easier to go through equations, especially in like science class and physics class. They use t's instead of, other regular variables. Whatever. I do the same thing for f's, because when I draw my f's, I always go like this. Yeah. Anyway, back to this. So I'm looking at this problem, and I got to solve it because it's set equal to 0. I got to use the Tucker method of factoring. So, Tucker method of factoring, what's step number 1? Step number 1 of the Tucker method of factoring. Step number 1. Nope, that's step 2. GCF. So I'm looking at this equation. What's my GCF? What can you divide all 3 terms by? You could totally divide them by 4. Unfortunately, that's a common factor, not the greatest. It's 8. 8 is the greatest common factor, but I'm going to caution you real quick before you start doing anything. I need my A value to be positive. I need my A value to be positive. I am going to take the 8 out, but I'm not just going to take a negative 8 out. You could do that if you wanted to. You could move everything over to the side. I'm going to save myself a step. Instead of taking out an 8, I'm going to take out a negative 8. I'm going to divide all three terms by negative 8, ultimately getting me that. You could move everything over to the left, and that would totally make that A value positive. You could totally do that, but I'm going to save myself a step. I'm going to save myself some headache. I'm just going to do something like this. It makes my life a lot easier. Now I'm going to do A times C. A times C would get me, what, negative 30. Because I'm only dealing with what's on the inside of those parentheses. I get myself a negative 30. What are my two magic numbers then? What are my two magic numbers then? I need two numbers that multiply to negative 30. Oh, because 2 times negative 15.
What? What'd you get negative 15?
Remember how I divided everything by negative 8? Yeah. So let me back up. Divide that by negative 8, you get 2. Divide that by negative 8, you get negative 1. Divide that by negative 8, you get negative 15. Then A times C got me that negative 30. Because I'm continuing with the Tucker method. Which one's negative? Yes. 5 and negative 6. 5 and negative 6. Again, with the Tucker method, after you take out that greatest common factor, you only continue the Tucker method with what is inside the parentheses. That's where you really want to focus your attention. So I'm going to go to a T-chart. I should change markers. Go away, marker. For those in the chat, I made that shot. 5 and negative 6. Do you remember what goes on the top of the T-chart? Remember, it's a 2t squared. 2t and 2t in this case, because something's going to simplify in a moment. Since it's a 2t squared, I'm going to do a 2t and a 2t. 2 over 5, keep it. 2 over negative 6 becomes a 1 over a negative 3. Keep the negative on the bottom. I end up with two answers. 2t plus 5 and t minus 3 equals 0. This is going to allow me to get two answers, definitely. What those two answers are, well, I'm going to get an answer of negative 2.5 because I set this equal to 0 and solve. And I'm going to get an answer of positive 3 because I set that equal to 0 and solve. I got me two answers, as I typically do. Which answer works? The positive one definitely works, but now here's the key. Yes, most of the negative answers we typically ignore, but there's a reason for that. In number 1, we ignored the negative answer because it was a negative length. In number 3, we ignored the negative answer because they wanted positive answers. Why are we ignoring the negative answer here? What does that mean? You can't travel backwards in time?
I mean, if you have light speed,
Oh, technically, Einstein proved that you can only move forward in time.
yeah, but like,
Moving at light speed is like taking a piece of paper and folding it together, and then poop, you pop through a wormhole. I understand it's relative. You're thinking interstellar. Yeah. you'd also be dead. The closer you get to the speed of light, the more your mass compresses. So when you reach the speed of light, you would actually be compressed basically to like a pinpoint of space. You'd find a way around that. You'd be dead. Now here's the thing. Check this out. Boom. Definitely. Your answer is definitely 3 seconds. That's your answer. But look where the negative 2.5 came from. Yes, you can't go back in time, but more specifically, you're not throwing the rock backwards. You're throwing the rock forward in time. Einstein did prove that you could time travel forward in time. You just can't time travel backwards in time. Actually, have you ever heard the concept where, okay, imagine a machine that was actually capable of time travel in the following sense. You turn on the machine October 1st, 2020. And the machine stays on for 100 years. Just stays on, okay? And then after 100 years, October 1st, 2120, somebody turns off the machine. After October 1st, 2020, you walk up to this machine, you can open the door, you can step inside, and you can travel to any point on that timeline within that 100-year span, as long as the machine remained on. And then you can step out. You can get back in that machine, adjust the time, and you can go to anywhere on the timeline. So, for example, today is October 1st, 2020, right? Here's when the machine was turned on. Here's when the machine was turned off, October 1st, 2120. You had a 100-year span. So as long as you are actually living within that time span, you could enter the machine and then go to any other point on that time span. Yeah. But if you go to the end of the time span, step out of the machine, and the machine is turned off. That's an issue. Now you can't get back. You're stuck. Unless you can find another machine. Yeah, you can't do that. Yeah, you can't go back to before when the machine was turned on. Anyway, back to this. Ladies and gentlemen, I'm going to tell you right now, number 7 is a challenge problem. I'm not actually going to go over number 7, but I am going to wrap up today, 11:05. I'm going to wrap up today. When I said wrap up today, you were like, already? No. But I'm going to wrap up today with number 5. Now, I'm going to set up number 5 for you, but I'm going to leave it to you to solve on your own time. I know. It was less smooth. It was chunky. Now, what I'd like to do is set this thing up, but then you are going to solve it on your own time. I'm not going to collect anything. This is more along the lines of you doing this on your own, because hint, what I'm going to show you, hint, what I'm going to show you is going to help you with your project. Hint. Hint. Anyway, here's the setup. There's a rectangular pool surrounded by a walkway that has an equal length all the way around. If that's the case, then here's the visual. Now, on the video, remember we talked about the video I made for the project? On that video, I show you a similar problem involving a garden. I would suggest reviewing that particular video in order to prep for your project. Now, the pool itself is 50 feet by 20 feet. Do you know the width of the walkway? No, you don't. So what are you going to label the width of the walkway as? Sure. Check this out. X. X. The width of the walkway is X. In every direction, the width of the walkway is X. There's X. X. Width of the walkway. Now, just for the sake of argument, check this out. What's the height of this whole thing? Look where my pen is going right here. Look where my pen is going right here. The height of the whole thing. I get a width of the walkway. I get the height of the pool. And I got the width of the walkway. 20 plus 2x, yes. Or you could do 2x plus 20. Either way works. 20 plus 2x. Zoom out a little. You could do the exact same thing for the bottom. Yeah, the exact thing for the bottom, 50 plus 2x. Now let's leave that alone for just a moment. The area of the whole thing is equal to the area of the pool plus the area of the walkway. The area of the whole thing is equal to the area of the pool plus the area of the walkway. What's the area of the walkway? They tell you. And what's the area of the pool? That one they don't tell you, but you can figure that out in 2 seconds. You were close. 50 times 2 is 100, so it's 50 times 20. There you go. So the whole thing has to be 1,456 square feet. But now the area of the whole thing is this. What shape is that pool area? Rectangle. Length times width. Length times width. Let me do something on the board. I'm going to do you one better. I'm going to take you an extra step. Because again, you can finish this on your own time. I'm going to take you an extra step. Check this out. You got to multiply those two things together. 50 times 20 is 1,000. This gets you 100x. This gets you 40x. This gets you 4x squared. Combine some like terms. You got 4x squared plus 140x plus 1,000 equals 1,456. Here's the purpose. I know I apologize. You guys can't see the entirety of that box method when I multiplied on the inside, but here's the purpose of me showing you this. You can take a word problem like this. You can sketch out the idea of what it looks like, label a bunch of stuff, and you can eventually turn that picture into a quadratic that you can solve. You get one side equal to 0. You begin performing the Tucker method, GCF, A times C, all that good stuff. And eventually you get it down to 2 answers where only one of them will work because the X value is the width of the walkway. It's going to be the positive answer, which I guarantee for this problem, it should be a nice looking answer. But I'm going to leave that to you on your own time. In the meantime, ladies and gentlemen, the bell's going to ring in about a minute. So I'm going to sign off in the chat, but I'm going to remind you, check Google Classroom. Those assignments are there. The project is there. The video is there. The PDF of the project is there. Read it over. If you have any questions, email me and make sure you're watching that video. In the T-chart. Here, I'll show you. End stream.